Welcome to Coding Adventures. In this episode, we're gonna implement this. Not the game, just the intro screen. So basically what we're gonna try to accomplish is to make some objects move around the rectangle. Exactly like these small little frogs are going around this rectangle. So let's get started. Alright, so we are here in the code editor with a blank code page. So we have to write this an algorithm to make perhaps some circles move around the rectangle. And I'm sure there are many other ways to achieve this one. But the way we're gonna think about doing it in this video is the following. So this is our rectangle, and first we like to have a small ball, like a circle, go on this rectangle, and the ball of course will move to the next position here, and then we'll travel this way, and then at one point after it reaches the end, we're gonna start going down, and we're gonna move this way, and then this way, and then this way, and then everything will just repeat. And for now, so step one, we're gonna start with one single ball to move it. Then in step number 2, we're gonna start and add to move a series of balls, basically, exactly like we saw those frogs going. And the way we're gonna do it is the following. First of all, we need to create a function. I'm thinking to create a function, something such as linear to rectangle. Let's imagine we take this rectangle that is made out of this line, and then this line, and then this line, and then this line, right? So the line number 1, 2, 3, and 4, and we just make it linear. So we have the big one, then a small one, then a big one, and a small one. So this will be the lines 1, 2, again 3, 4. So we need to create a function where I'm intending to create a function that if we're gonna fit this function with a number, let's say number 0, we're gonna just place the circle here, basically at the beginning. But then if you fit the number, let's say 50, we'll just consider the rectangle as one line, and if 50, for instance, will happen to be here on this line, we'll actually place the circle here, and we'll just wrap up. So if the entire size here is, let's say, 100 pixels, if we just specify 50 should have been in the middle, if we specify 100, it's at the end, and then just wrap up. But if we think of the problem in this way, we'll be able to come up with this function that if we provide a number, it will basically tell us on which of these segments that number is located, and at what position from the beginning of the segment. So in this way we can increment. So we start with an I, imagine to move the ball, we start with an I0, and then we increment it. We can increment it forever, because if we'll just wrap up around this one, it will just wrap up around the text, around the rectangle. So then we can increment by 10, so this will be the 20 position, 20 position, 30, and so on and so forth. So let's have this function name function linear to rectangle, and let's say we give a linear x, we give a number, and now this number is those numbers that I mentioned from 0 to 100 or bigger, and now we have to specify how big is the rectangle. So rectangle x, or to define the rectangle, rectangle y and rectangle h. I'm not specifying just the width and height of the rectangle, I'm specifying also where it starts on the screen, because we can make this function return the coordinates, basically, either if it's on one of these axes. So let's figure out what is the width of the entire rectangle. So obviously is the rectangle width plus rectangle h, these two together, times 2. And now whatever number we are providing it, we can take it modulo linear x modulo w. So it will wrap up around the rectangle, right? All right, so this should achieve the, so here, let's say, make sure the dot is on the line /rectangle. and W is basically the width of the rectangle. And now let's check if the dot, imagine that dot that is moving, let's check if it's on the top side. Check if dot is on top side, and we can check very easily if linear x, so it's we could name it x, I'm not sure why I name it linear x, is less or equal than the width of the rectangle, so for sure it's on the top part. Switching back here into the to the diagram, so if the number that we are providing is less than, this is the width of the rectangle, width. So if it's on this interval, for sure it's on the top margin. And then if the number is not on the top margin, but if the number is less than this L plus this L, then for sure it's on this one, and so on. So we're gonna rationalize in this way and move on the rectangle. So if it's on the top margin, let's return then what is the x and y coordinates of the dot. So the x should be basically wherever the rectangle starts plus this number, because we want, these are absolute coordinates, right? And the y, it's wherever the rectangle y is. It's exactly on the top margin. Now let's do the other one. Check if dot is on the right side. In this case, the dot is going from left to right, so basically in clockwise type movement. So at this point, we can, since we are returning here, for sure we can check directly if linear x is less or equal than this one, exactly as above, plus the height. And then in this case, return x is basically it's a rectangle x, it's plus rectangle y, the rectangle w, this coordinate here is on the other side of the rectangle, and then y, it's exactly at rectangle y, and now we need to, is basically at the delta, we can add the linear x, and then we subtract the rectangle height. Looks correct, right? So looks correct. So let me type really quickly here to see times rect w minus rect h, and we closing. All right. So our function should be ready at this point. What we can do, we can test it. So it returns an object. Let's say it's at 20, and the rectangle we can start it at 0, 0, and can be 150 height, right? And let's display o.x and o.y. All right, eventually separated by some space. Yes, is that 20? And should go up to 100, so it's 99, should be still on the top margin. But if we go 120 here, we should be 100 at maximum on horizontal, and then go down 20 pixels, which is correct. So let's assume the function is correct, and instead of just playing with it like that, let's implement some sort of a loop function and see how it works, right? So let's implement a function loop here, and inside the function loop we're gonna call update and display the typical pattern. Let's save the function update and function display. All right, and instead the display, we're gonna clear the screen. And let's have an x variable that will keep the coordinate of a, let's say, of a ball that we want to move it to the rectangle. And inside of the update, let's increase x by 10 pixels. And inside the display, let's just use the linear to rect function to calculate the coordinate of the ball on the rectangle. So let's say this is the object O, it's linear to rect, and then we pass the x variable. And we define an arbitrary rectangle. Let's say it starts at 100, or let's use that rectangle at 0, 0, 150 height. And then for the return variable, let's display a small circle at o.x and o.y and a certain radius. And if we'll run it, a small circle running around on a rectangle. So our function is correct. As a matter of fact, we can also put it in the middle of the screen a little bit here, perhaps even here, make it 500 and 300. All right, so goes around the rectangle. Let's display that rectangle there. So it's not optimum what we are doing here, but we're gonna remove the code anyway. So we're gonna display a rectangle at these coordinates. And let's run it. And indeed our circle is moving around the rectangle. Yeah, let's clear up the code a little bit and let's display more balls, shall we? So instead of x, let's have here perhaps a config. Let's name a variable config of type object. It will be an inline object that will basically contain the configuration of this movement on what rectangle. So the rectangle, maybe we should make a rectangle starting at x50 and y50 and width 700. We'll make it really big, so basically almost the entire screen, and the height is basically 500 because the width is 800 by 600 in this canvas. And let's have a variable, the number of balls. Maybe we should have 75 balls that we want to move around. And the first one, let's say the first x, the x of the first ball, like instead of this x variable that we used for the small demonstration. And this one starts at 0, exactly like our x was starting at 0. And we can also have a variable 1, 2, 3, a variable that will use it to define the speed, because when we use a single ball, that one was moving kind of fast. All right, so we have this config information here, and what we are writing inside the update here, well, we want to update. Okay, so we have the config, and now inside the update, what we can do is just update constantly this variable. The rest are just constants. Maybe we should have kept them separately, but it's fine also in a single structure. It's like, this is the system, is the ball system. It contains also static variables, but also dynamic ones. So inside here, we can say config.first x equal, we just add to this one config.speed, like this. And let's see what we are displaying. So basically we want to display all the balls, right? So let's have a for loop for let I equal 0, I less than config dot, I think we put a variable no balls, right? I plus plus. And let's create a function display ball that will display the ball number I. So function display ball, and we'll display the ball number I. So the way we're gonna do this one is the following. I'm gonna switch back to the notebook here, and let's remember again this linear thing. So we want to display a number of balls. So we want to display, in a sense, they are on a linear structure, right? So if on this linear structure we have to display 3 balls, so we'll have to place the first one here, the second one here, and the third one here. But what if we want to display 4 balls? So, and we want equally spaced out. So if we want to display 4 balls, we'll place them like that. So the way we're gonna do to figure out the x and y, or just x, because we are thinking in linear terms and then we are converting them to rectangle, we're gonna look at the entire width of this linear space, and then we're gonna figure out what is the space between balls. So this is the space between balls, which is obviously the entire width. So is the entire width here, and then we are dividing it by how many balls they are, right? So we are dividing it by the number of balls. So this we're dividing by 3. In this case, by there are 4, we can divide it by 4. We can adjust plus minus 1, but basically we're gonna figure out this space, and then the x of a certain ball is basically the first x. We always keep track of the first one, so this will be first x, and to this one basically we add which is the ball number, so the number of ball, or I. We can use the variable I inside the code, and multiply it by this space, and we figure out the x. And once we figure out the x, we convert from x to that rectangle OX and OY, and from this one we can do a circle at these coordinates OX, OY, and a certain radius. All right, so this is kind of the algorithm. Looks kind of messy right now, but let's try to write it into the code. What is the width of the entire line, the linear line? It's starting from here. It's config.width plus, okay, we can start from there. So the width is config.width plus config.height, and then multiply by 2. So this is the linear width, and now space, we can divide this one by the config dot how many balls, number of balls, and I think we can divide it by number of balls minus 1. Yeah, if we not look right, we can adjust this one. And now let's figure out what will be the x for a certain ball. So it will be the config dot first x, the x of the first ball, and then we are adding to this one the number of balls, so the I multiplied by space. So we figure out what is the x of a particular ball. Let's run this coordinate to the function linear to rectangle, and for this one we're gonna put here the ball x, and then the rest are config.x, config.y, config.w, and config.h. All right, so we put it here, and like we said, we can display a circle already, o.x, o.y, and a ball of certain radius, let's say a 10. Balls around the rectangle. Let's save it, run it, and see what's happening. All right, so looks pretty cool. We can adjust the space here, but I think it doesn't matter. There are so many. -1 we said initially. If we run it, probably won't see any big difference. But yeah, the balls are moving, and let's try to play with fewer. All right, we can keep them this size, or we can make them smaller size. Let's make them a little bit smaller, perhaps 8, and let's ink it back here, 75. All right, I like how it looks like. Now, instead of being just empty circles, let's color them. So let me quickly go here and define some colors. What we can do, we can have some predefined colors here. So what colors do we like? We like red, blue, orange, green. Let's create a series of colors: red, blue, orange. Some really nice colors, like also as random as possible, because we want to pink. Let's put also, after pink we can have a yellow, we can have a teal, you know, as many colors as we want. And now let's go inside that display function and basically use a fill command, somehow wrap around the colors here. So we'll go inside the display, and let's use, before we draw the circle, let's use a fill colors, of the ball is I, but we are taking modulo colors.length. All right, let's run it. Let's eliminate the stroke. So we can go probably in the display here and say no stroke. And if we run it, looks pretty clean and nice. It's not exactly like in that game, but give me 1 second and I'll try to bring up a background and something really interesting here. So let me put a background actually here. What background do we like? I don't know, maybe this green pool. So let's go here and say background green pool. Let's run it. We can put also a little bit of music. We can write some text here and then say press S to start the game. I won't bore you with these details. Actually, give me 1 second. I'll be back. 1 second. All right, I'm back. I just beautify a little bit the code and also added a few extra interesting details. So let's run now the code. And these are our balls going around the rectangle, and I put a few decorations, this text here, a few decoration, and press S to start the game. Of course, S doesn't do anything at this moment. It's up to you to create an interesting game. You name it however you want. I just said here Candy Mash, but it's up to you if you want to create a beautiful game with this kind of old school intro screen. I hope you like the exercise. Until next time, happy coding and see you next time.